Hello and welcome to HCT's presentation on breakthrough technology for water, soil, and vegetation. So when we talk about breakthrough, we're going to tell you to say goodbye to a lot of problems that you experience in agronomy. Water quality challenges, things like fairy ring, blight, dollar spot, localized dry and wet spots, standing water, hard pan, ball marking on greens, algae, black layer, stuck sprinkler heads, shells, typical problems caused by water and soil. We're also going to ask you to say hello to some pretty game-changing attributes from what we do. So we change infiltration rate and depth of water. We're providing a product that does continuous chemical aerification from water, similar to what rain does. As we remediate soils and treat water, we start moving accumulated soils, nutrients into available nutrition, which causes more pore space in the soil. That causes the reduction of what they call bulk density of the soil. We're probably the only product that I know of in the world that directly detoxifies sodium. We convert complex minerals and metals in soils into available nutrition, where during the evaporation to dryness phase, they don't recomplex. So once they're converted, they'll always be hydratable. A lot of this leads into vegetation vitality for both turf, agronomy, and as well soil uniformity, which leads into crop and turf uniformity. The water use efficiency is pretty dramatic by getting water into the ground and letting your plants get the water when they need it. We typically see reductions in water demand in excess of 15%. The efficiencies that we cause are significant reductions in cost and substantial savings. What we do is based on data, so our agronomical predictability and the ability to remediate soils is all predictable. We look at the environmental fate, the soil fate, the water treatment chemistry fate of what we do, so we don't have anything that's going to accumulate or collect, so we call it ongoing sustainability. And there's nothing better than having happy owners, happy management, and happy membership, as well as happy agronomists and happy growers. So we welcome you to our company. We're called HCT. We have an exceptional team, and our objectives are to exceed customer expectations. We're blessed with chemistry that does it, but then we have to execute the deliverables of that technology. And so we strive to meet your needs immediately, quickly, with intellectual knowledge and data that's scientifically irrefutable, that's to the point, so that when we write a prescription, the patient gets well. We developed a technology, it's called the legacy test methods, and these are improved methods at which we look at water, how we look at soils, and how we look at what the plant is drinking. And how we look at soils is also a baseline for what's in our soil and what we should add and what we shouldn't, and how we should treat water to react with those soils to provide our plant the drinks that they need. And then comes our WaterSOLV products. So we developed injectables to start with, but we found a lot of people wanted to do topical evaluations. So we developed some topical products so that people could spray it on. These products are also used for spotting chronic bad areas, give those areas a little more medicine topically, and then they can use these products for evaluation. And then we have our injectables, super concentrated, One is super fuming, one you don't want to get on you. And these are to treat water and then put additional chemistry in to remediate the soils. And then eventually we'll reduce the amount we put on because the soils have been remediated. So now we're really just treating the water, the added fertilizers, and sustaining that soil integrity from numerous viewpoints, which we'll discuss later. And then we had to get the product out. So there's a lot of injectable solutions out there. We tried to find companies to work with us to build systems the way we needed them, and we finally had to do it on our own. So we developed chemigation systems for the agronomical side of the business as well as the injectable side of the business, which applies to landscape and turf and sports fields, etc. So what we don't do is we don't remove soil compaction. We treat soils in open pore space, etc., but not compaction. Compaction from traffic, golf carts, etc. The other thing we don't do is we don't sell fertilizers. We don't sell pesticides. We don't sell ancillary products. We sell chemical technology, intellectual knowledge, analytical testing, and a way to get the chemistry out. What we do is pretty substantial. So we have proprietary chemistry, the testing, the analytical knowledge, the consulting. We fix water and soil. We create optimum vegetation production. We do that sustainably. We do it by reducing cost, and we increase revenues. We'll make you money. You'll probably realize a lot more money in your pocket than you'll spend on our program. And usually it's greater than double. So, water quality made beneficial, water treated to remediate soils and vegetation problems, water treatment adjusted to sustain soils, and vegetation optimization. You have one growing season to make a yield. And so it's important that the water and the soils are functioning optimally for your vegetation so that when it drinks, it's getting everything it needs for its optimum vitality and production. Our technology is scientifically validated, which I'm going to get into details. I'm putting this statement in writing. It sounds atrocious, but better than rain and better than RO water. More agronomic and economic value. It's much less expensive, and it's got a significant return on investment. So what's the process? How do we go about doing what we do? It all starts with analytical testing. Improved methods to understand other characteristics about your water versus the normal characteristics, which I'll get into. We write prescriptions for water treatment, soil remediation. We inject the chemistry. We might do some topical applications in troubled areas. We put out the numbers to show you what it's going to take in your budget. So what's the cost of the chemistry? What's the cost of the chemigation? What's the cost of the analytical work? What's the cost of the analytical analyses initially and down the line? What are the savings versus the costs? So how much money are we going to save you on various aspects of what you're doing today? What's it cost to install? What's it cost to maintain? And then the tracking and the accountability. All those systems are in place. So optimum vegetation vitality in turf quality, in crop production, and in soil health. It impacts all vegetation exposed to the water. Trees, shrubs, drip lines and emitters, everything exposed to the water has a positive impact. More value, more benefits, more revenues, and the more people you have, the more commissary you make. So what is our chemistry doing? So when we're treating water, what we're doing is we're sequestering the minerals and the metals in the water. And by sequestration, what that means is we're preventing them from forming scale. We're preventing them from complexing. When they evaporate to dryness, they typically will crystallize like a hard water spot. The harder the water, the harder the spot. The harder the water, the more accumulation of salts you have. Fertilizers that you put out, even in a container, they want to crystallize. When you put them out on the soil and the plant doesn't drink them, then typically they'll evaporate to dryness and they'll crystallize. So by sequestering the salts, they'll never crystallize. When they do evaporate to dryness, they're a powder, and you can actually take that powder and dissolve it just from the moisture of your skin into your skin. And we may incorporate an antiseptic. So water and soil, like if you turn off your pool, it's going to go bad. Bacteria is going to grow exponentially. You got to chlorinate, you got to brush, you got to filter. Well, how do we do that in soils? Well, if we can keep that bacteria at bay, then we don't have to fight the bacteria and all the exponents that it creates. So a lot of times, based on analytical data and the food source for bacteria, we likely will prescribe an antiseptic. We're going to convert soil-bound nutrients to sustainable, available nutrition. So all the fertilizer, all the hardness, all of the minerals and metals that have accumulated in your soils, we're going to break them down and sequester them so that when your plant takes a drink, it's going to be able to get those just as easy as it can get sodium. And we're going to detoxify sodium and chloride. There's also confining layers that can be involved. So detoxifying sodium and chloride, we're probably the only company that can run 1,000 parts per million of sodium and chloride through a tissue sample, and it doesn't cause damage whatsoever. In a lot of cases, we've been ripping our soils at 12, 18 inches. We've developed, or we core aerify and top dress, and we develop these confining layers. Well, these confining layers will hold toxins. So we have to make sure that when we start getting chemistry down into those confining layers and our root zones get down to those confining layers, that those toxins are mitigated with chemical addition. So part of the byproduct of the antiseptic product is that we're actually adding dissolved oxygen. So like rain delivers dissolved oxygen, we're adding it through our chemistry as a byproduct of the antiseptic. So we call that continuous soil chemical aerification. Your plants need oxygen. They need oxygen uptake. It's essential. We talked about the less water. We have typically, everybody realizes 15%, and we'd have golf courses and agronomical situations where they've realized 40% less water. Certainly there's environmental factors that play with that, but we had four golf courses in Texas. 2 were on our program, 2 were off our program. The 2 courses on it saved 40% of their water demand, while the other 2 courses actually exceeded their water budget. And then there's the improved conditions, efficiencies, and vegetation vitality. So the resources of managing turf and soils, managing agricultural soils, the availability of nutrients, the nutrients you put on that already exist in the soil that you can harvest from your soil, the detoxification of toxins, the reduction of diseases, the physical agronomical practices that you have to go through, all of those are significant reductions in your costs, your resources, and improvements on your efficiencies. But it's not all about us. It's all about your client. It's all about our dealer. And it's all about HCT's intellectual knowledge and their proprietary chemistry. So we have the solutions. We understand how to identify and solve the problems. And with all of that, the 3 of us become trusted advisors for the grower, because what we say is going to happen and when it happens is our art. And this is what has made us successful for quite a few years. So with water and soil, the properties are all the same. We have minerals, we have metals, we have microbes, we have toxicity, we have bio wastes, which are usually toxins, and then we have soil physics. So we're taking all of this into consideration when we're looking at a client's needs. And the only way we can do that is through this improved analytical data. We have to have the good data. We have to have all the water, all the data on the water, including the bacteria. We have to have all the soil data. We have to see everything that's in that soil. And then we have to know what water through that soil is producing for that plant to drink. And so we can look at what your water is doing through the soil and what it's producing. We can look at what your treated water through the soil is producing for the plant. And then we can treat your water with our material and run it through the soil and show you what that plant is drinking. And then we can adjust the treatment in order to make sure what we're putting through the soil is making that positive drink. So client necessities, water treatment, soil remediation, followed by soil sustainability. They've got to put the product out, and then they want to be they want to know what the assurances are. It has to fit within their budget. They're really interested in predictable results and timing. You know, in agriculture, you've got one season to create the most product you can, and that's where your revenue is. So predictable results and timing. If we have soils that are really bad, then we may have to hit it really hard in order to start getting that treated beneficial water into that desired root zone. And then they want accountability. So they want to track, they want to see what's happening in their soils. They want to see what's happening in their available nutrition. So we're able to do that with the data that we produce. So a lot of people say, well, you know, so what is the workflow and timing? Well, on our part, we have to have that analytical data. We have to understand the client's equipment needs. So we got to get samples to the lab. Lab does the work. They send it to us. We package it. And that's about a 2-week process. And in that information, we can determine what their application rates are, what their soil remediation rates are, what the cost of the technology is, what the cost of the equipment is, what the cost is per acre foot, per inch of water, et cetera, et cetera. All that comes off of one sheet based on the analytical data. And then the clients wanting to know the cost and timing for the remediation, for the sustainability, for the equipment, will their existing equipment work, et cetera. We're very dialed into that. And then there's savings. So cost is one thing, but savings is another. And if you go spend $50,000 and make $150,000, you're $100,000 ahead. So it's really important for us to allow our clients to say, hey, if we eliminate this and this and this and this and this, how does that add up to the bottom line? If we increase your production this amount, how does that add up to the bottom line? And look what it's going to cost you to achieve that. So all of this is accomplished 2 weeks to compile all the information, get the data, and then it's only 1 to 2 days after the receipt of that that we can provide all that additional information. So something to think about on the technology side is that soil is a filter. So similar to your refrigerator water, you have to change the filter on the water that you get through your refrigerator. Why? Because it gets plugged up. On your vehicles, you have to change the gas filter. Well, it's gas. It's probably one of the best solvents out there, but they have to be changed. Why? Well, they get biology in there and they get plugged up. Air filters have to be changed. Air filter on your car, air filters on your home. Why? Because it gets plugged up with matter. Think about your pool. When your pool gets upset, you can shock it, you have to brush it, but you also have to filter all of that matter out in order to maintain that clear water. So how do we clean soil filters? Well, we're doing it chemically. And I'm going to get into the details of that, but we're making the water a better product so that it can sequester what wants to plug up in the soil, prevent what's in the water and the fertilizer added from crystallizing in the soil, and then taking those crystals in the soil and breaking them down and making all those minerals and metals and fertilizers as soluble as sodium. So we wind up reducing the sodium percentage, increasing the nutrient percentage, and so your plant's getting a healthy drink as well as oxygen. So that's what we do. All right. This was a video. I'm sorry. This was a lab test that we did, and we got some really, really bad water and sludge. And so we wanted to react it in our acid. And so lots of acid, pH of 0, several days, and you can see in that first beaker it left matter. Okay. Then we said, well, let's use our antiseptic and do the same thing. Lots of antiseptic, let it sit there and do its chemical reaction for 3 or 4 or 5 days, see what we wind up with, and we wound up with matter. So matter plugs pore space. So I said, all right, let's take both our acid and our antiseptic and do the same thing. And guess what we got? We got very little matter, and we put everything into solution. Now, all of that is drinkable. Now, if all of that was sodium, that would be a bad thing. But if all of that is biomatter and all the minerals and the metals that were tied up together, so they were tied up in the calcium and the biomatter, and we disassociate it, well, we could move particulate matters built up in golf course greens down into the flush. We could liberate zones in agriculture, et cetera, so that we can get water down, get nutrition down, open up pore space, and deliver those root zones the beneficial drink that they need as well as the oxygen. We also say, and it's been slow for people to adopt this, but you have to disqualify the need for the antiseptic. When you have bacteria in your water and you take that bacteria, well, none of you would probably swim in the pond water because why? Well, because it's septic. Septic means a lot of bacteria. However, if you take that water and you spray it out on the golf course, that water looks beautiful, like you want to run through it. It's nice and clean, etc., but it's not. It's loaded with bacteria. So we take that bacteria, we throw it out onto the soil, and the bacteria goes, wow, this place is great. It's got all my sulfur, sulfate, iron, manganese, phosphate. It's got everything I need to build a family. Even in pipelines, bacteria will find ways to find a place to set up, and they'll absorb all these nutrients and they'll build these nodules and incrustations, etc. And shells, you know, the zebra, quagga, Asiatic shells, they'll find little areas in eddies in pipelines and go, okay, I can sit in here and I can absorb my nutrients. I can build my house, which is the shell, okay, and then you depressurize that line, the shells fall out because they have no holding on power, and you wind up flushing them to the end of the line and you got plugged up sprinklers. So if you deal with the embryonic form, if you deal with the bacteria in its elemental form, then you don't have to fight what it's going to produce in the environment that sustains it. So it's not so much the bacteria that causes the problem, it's their waste products. So the sulfate reducing bacteria, which is also known as black layer, they produce sulfuric acid. Well, that's great, but also with that comes a very, very toxic hydrogen sulfide gas. That's that rotten egg, stinky feet smell. That's toxic to plants, and its gases are very, very soluble, so plants will consume gases. If you hear a root rot, black layer, disease, a lot of that's attributed to sulfate reducing bacteria. It also produces water. So when you get these soggy areas that never dry out, that's usually a biological problem caused by sulfate reducing bacteria. If you're in the agriculture or drip line business, you fight iron bacteria, and iron bacteria produce biofilms, kind of like a liquid saran wrap. And it also produces water. So if we can treat the water bacteria, then we don't have to fight all the bacteria that it can produce. And when it's warm and stagnant, or it's in the soil, these bacteria can actually reproduce themselves every 15 minutes. So if I've got 10, then I can have 100 in 15 minutes. And if I've got 100 times 100, then I've got even more. So they grow exponentially. There's also this concern about acidified nitrogen. So one of our go-tos is nitrogen, calcium, nitrogen. And when we build up nitrogen in the soils and we acidify that nitrogen, it can actually reduce what's called amines. And amines it's kind of a monomolecular chemisorbed film that gets onto root zones and will actually block nutritional uptake as well as oxygen uptake. So that's something that's really important. And the only way that we can break down those amines and prevent or reduce that problem of accumulated nutrition and the production of amines is to add dissolved oxygen and add an oxidizer, which comes from the antiseptic. So this is just a little study that was done a few years ago. We were actually trying to damage turf by applying our acid and our antiseptic. And we were supposed to be able to have this test for 30 days. It got cut short to 12. And this is the amount of black layer that was moved in just 12 days of putting the chemical onto this soil every other day for 12 days. So 6 days of treatment. And we did do some needle tine aerification just so that we could get the water into the soil quicker because of the shorter time that we had. We didn't do core aerifying. We just punched little 3-inch holes to be able to, kind of like putting an IV in the blood, trying to get the chemistry into the soil. And that was the change that occurred. Now remember, that black layer produces hydrogen sulfide gas, which is toxic to turf. These are two different places. So on the left, just goes to show what the application of our chemistry did to improve the infiltration rate and reduce the bulk density on 3 various greens. The last one, the bulk density went up. We didn't quantify why, but I think this was over about a period of 3 months that we moved the infiltration rate from those numbers. And then on the right, that's out of Florida where they get plenty of rain. So on the left, they said, whatever you're doing, keep doing it. These greens' physical properties are excellent. And that was based on a green soils analysis by the International Sports Turf Research Center. On the right, this organization owns 22 golf courses. And their comment was, we've never had greens look this good. This is in Phoenix, Arizona. It's a place called Arizona Country Club. Another ISTRIC soil analyses, and their comment was, after 4 years on the WaterSOLV program, the sand profiles look as good as new 22 years later. Just give us a little credibility. This is in Myrtle Beach. We looked at their soil and water profiles. We prescribed a product that we have called Grow. Grow is primarily the antiseptic with a little bit of the acid. And after just a few months of topically applying the product, they sent us this picture and we wanted to share it with you. They also get a lot of rain and we're having problems. This picture is out of Florida as well. So chronic industry problems resolved. So what do I mean by chronic industry problems? I'm talking from Washington to Idaho to San Diego to Phoenix to the tip of Texas to Oklahoma to Maine to the tip of Florida. These are chronic problems that everyone experiences, and they usually fight it by physical soil removal, top dressing, burying the problem, etc. So we listed out a few here. We have a very, very long list, which we'll give you a link to at the end of the presentation, and also have a sheet to show you that. But restored soil operability, sticking spray heads, shells, struggling vegetation, bad water quality, infiltration rate and depth, transition at golf courses, playability, water retention, um, uniformity, disease such as fairy ring, dollar spot, canker, blight, black layer, iron bacteria. All of these things are addressed by this simple program. Talk about some of our credentials. So we're registered with the American National Standards Institute, Underwriters Laboratories, OMRI, National Organic Program, NSF 60, the National Sanitation Foundation for water in contact with potable water systems, and then the Standards Council of Canada, as well as the California Department of Food and Agriculture, who doesn't allow you to use their logo. So with the California Department of Food and Agriculture and with the National Sanitation Foundation, you'll see that little sticker on anything to do with potable water things, chemistry, equipment, piping, etc. We are actually certified by them. So what that means is that they looked at our chemistry, they looked at our label, and they gave us certification. And with that certification comes auditing. So they audit us, they come to our factory, they analyze the storage of our products, what raw materials we're using, they take samples of our materials, they test them, etc. And so we're under extreme scrutiny from those aspects. So certification means that chemistry and label align with scientific efficacy. With OMRI, they're just making sure that you're in compliance with the National Organic Program. They don't certify you, but they do look at the chemistry, make sure it's in compliance with the rules and guidelines of the National Organic Program, and then they list you as certified for the National Organic Program. So we've been around since actually 2013. We started out in water wells, and then we migrated into these other market segments. So just so you know, we have about 240 golf courses today. That's throughout the United States, border to border, coast to coast. We have about 100 nurseries that use our technology. We have probably well over 2 million acres of agriculture. I've written prescriptions for more than 1,000 water well rehabilitations. Most of those are municipal, city, potable water drinking wells. We've done quite a bit of industrial wells for people like Marathon Refinery and Intel. We have thousands of elated end users and dealers and engineers, and we're nationwide, coast to coast, border to border, which I mentioned. As I mentioned in the prior slide, the science is empirically proven. So not only did they look at the chemistry and certify it and the labels, but we've been out into all these places and we've proven those results and we've reproduced them and we've supported them with data. So it's a good deal, and we're very grateful and feel very blessed that we were able to put together what we have put together and the relationships that we have with our dealers and our end users. So I mentioned matured analytical data, so our testing is different and it's substantially different, and I touched on it. But the amazing thing is that we can sit from behind a desk with good data and we can write prescriptions and patients get well. So data to us is everything. People go, well, I just want to spray my green topically. What should I do? How much? How often? And it's like, well, I don't know your soils. How can I tell you if I don't know your soils? Because what I have to do is fix the soils to make that drink for the roots. So our tests, standard water tests are good. but we also include the bacteria because we have to know how much bacteria we're putting out onto that soil and their food sources and what waste products they potentially can make. Then we have to look at your soil, and I don't want to look at exchangeable, which you're accustomed to. And if you really do some research and look at what exchangeable means, it means, well, we're going to take your soil and we're going to digest it in water and this reagent, and it's supposed to mimic the acid that your root can produce to break down these nutrients so that it can drink them. Well, we don't subscribe to that whatsoever. We look at total soil composition, which typically will show us that you've got more iron, calcium, potassium, phosphate, and calcium in your soils than you ever imagined. And it's no wonder you can't get a probe in the ground. It's no wonder it's so soggy because your soil is loaded with all these nutrients. What we need to do is we need to make that water a better product to start reducing those pounds per acre of all these accumulated nutrients and toxins. So we look at the total, that sets the baseline, okay, of pounds per acre that we have in the soil, and it gives us that baseline to show next year what we reduced, but it also tells us eventually what we need to replenish and when. We take that water through that soil in an improved test. We don't use a 1-to-1 water to soil. We don't use a 12 to 24 hour soak time, and we don't use lab water. We use your water, hopefully spiked with our material. We use a 4-to-1 ratio of water to soil. We let that soak for 72 hours, and then we extract the solution to see what that client treated water is producing through its soil to make sure that that drink is significantly rewarding. The analytical testing is an online portal. So you can go on, you can book your water analyses, your water bacteria analyses, your available soil nutrition analyses, your total soil digestion, and the interpretations and recommendations. You can book them online, pay for them online. You can package the materials up, and then you can ship them to the lab. The lab will do all the work. They'll send it to us. We're going to package it. We're going to give you all the intellectual knowledge, provide it to you, and then we're happy to discuss it with you, explain it to you, etc. And it will completely change how you look at your water, your soil, and what your plant is drinking, and how you're going to manage your fertilizers. This will all roll into SAP analyses as well. So you'll be able to see these changes in SAP analyses. Hope I didn't create shell shock here, but this is the report that we put out. And so what we can do is we take your water, and we don't just give you a sheet of paper that shows you the water data. We're going to take your water, we're going to lay it out here horizontally under categories. So you've got a pH category, you've got a nitrogen category, you've got a cementation category, a toxicity category, a biological category, and then you have some transient categories like copper and computed percent sodium. Below that, we're going to lay the total soil composition. We're going to convert parts per million to pounds per acre so you can relate to that. Then we're going to take your water through your soil and show you what your plant is drinking. And so all of this adds up, all of this is trackable and accountable. We take the water data, which calculates the water treatment needs, and then based on the soil condition, we add what we need to add to the water to start remediating the soil. And then we might, because of your water quality, say, well, you need a little bit more of this or a little bit more of that product because chronically your water is going to cause these conditions. So we have an annual override, and then that determines how much chemistry we're going to use, what our annual usage is, how much volume that is, what the cost is, etc. So we kind of broke these into little cells for you so you could see them. Up here is the nitrogen. In the top left is your nitrogen. Then here's your bacteria, and the food sources for bacteria, the things that get tied up by bacteria, also that can help restrict available oxygen to the root zone. And below that, we have our calcareous products and the culprit that causes calcium and magnesium to crystallize. We have the elements in red here that calculate our sodium toxicity. So what we call the computed percent sodium, which we can elaborate on. Your plants cannot live on drinking more than 40% sodium. It should really be more down to 20%. And the only way to reduce that is to increase the percentage of the beneficial cations, which is the calcium and magnesium, as well as beneficial potassium and phosphorus. We talk about chloride. A lot of people don't realize that chloride, while it harbors sodium, it also can tie up iron, calcium, magnesium, zinc, potassium, phosphate, and it ties up boron. And then there's the physical properties of soil. So infiltration rate and depth, moisture percentage. I mentioned that the bacteria produce water. So are we reading moisture percentage of bacteria produced water? And then soil bulk density. All these things have a major role on what that vegetation is going to drink, what it's going to produce in crops, and soil health. And then our chemistries. So we started out with our injectables. So we have WaterSOLV curative, which is an acid. And then we have WaterSOLV BC, which is an antiseptic. And so our acid's going to go after the calcareous products, the beneficial cations, and the complex metals. And then our antiseptic is going to go against the exudates of bacteria that create toxic gases, that create toxic waste, that consume oxygen, and that produce biofilms that tie up micronutrients and tie up minerals and metals as well. And for people to evaluate our product, we came out with the WaterSOLV Fix and the WaterSOLV Grow. What we found was that the products for evaluating became also a topical spotting product. So those areas where water's always collected and need a lot more medicine than the overall soils, they could go out with these user-friendly products and apply these products to those troubled areas to help them get caught up with the rest of the soils. Fix is mainly curative, so it's mainly for calcareous issues, but almost always biology is active in those areas, so it has the antiseptic in it. On the other side of the equation, Grow is primarily the antiseptic, but a lot of times the calcareous products are involved in that matrix. So we have Grow, which is mainly antiseptic with a little bit of the acid. This relates back to those three beakers where the acid did a job and the biocide did a job, but the acid and biocide did the total job. So if we're mainly calcareous and we're doing topical or spotting, we'll prescribe the Fix. And if we know it's mainly biological, then we'll provide them the Grow, and it has a little bit of the curative in it. All right, chemigation. In situations where we have variable flow, we have to be able to put out variable amount of chemistry. So if my flow rate's high, my pumps have to put up more. If my flow rate drops, the pumps have to put out less. So that's variable flow. If I'm in agriculture, in a lot of cases, I may have a VFD, but it's slowly ramping up to a standard flow rate. I just need to set the pumps and turn it on. I don't need to worry about I'm putting out 3,000 GPM at one time, and then I'm putting out 80 GPM when I'm using a jockey pump or something. So we developed this controller. This controller is reading the flow pulses from a flow meter. Those pulses go into the computer and they say, oh, pump one, you said for every pulse, put out this amount of chemistry. Oh, and pump two, you said for every pulse, put out that much chemistry. Pump 3, you said for every pulse, put out this amount of chemistry. So that's all this box is doing. You tell it how many parts per million of chemistry you want to put out. It's reading the pulses received from the flow meter, and it's telling the pump, this is how many parts per million you want to put out. This system's designed to run 3 different pumps and feed rates, and I can piggyback more pumps onto each one. So if I need to put out more chemistry than the pump is capable of putting out, what I can do is add another pump and then set the feed rate at half the prescribed rate, and it will put out double. So it's really a great system. It's designed for our chemistry. A lot of people say, well, you know, I have a pump. Well, I'm putting out chemical at the rates of half to 1 to 2 to 3 parts per million, not 30 to 60 to 90. And I want pumps that I can support and that I know I'm not going to have trouble with. And if I do, I want to be able to curtail those problems so that we don't experience them. Also, these pumps are really easy to not upgrade, but to maintain simply by changing a plunger, and they're really good to support. And these pumps don't show it, but we actually have an improved label on them with words instead of icons so that people can actually understand what the button means and what you need to do. When you're using the system, the FS1 system, you're not adjusting the pump. It's reading pulses. So it's set at 100% and it's activating based on those pulses. Couple sample installations. The one on the left kind of shows the controller mounted on the wall, shows the little stands that we created to mount the pump over drums. And then over on the right shows, again, the stands over the tote and over the drums, and then how it's connected to the FS1 by electricity and by signal cables, and then the discharge of the pumps go into the distribution system. Our lab does a lot of interesting things besides compiling your data. Sometimes clients want to know chemical compatibility. They want to know comparisons between products. They may have a problem and they've been trying to solve it. They don't understand it. So we get called out on a lot of things to help them understand what's going on and how to solve those problems. And if I don't say so myself, we're really good at it. So that pump station on the right for 2 years has been getting pinhole leaks, and they bought the creme de la creme of pump stations, and they thought it was galvanic corrosion. Nobody could figure out what was going on, and you know, we'd heard about it at year 2, and finally at year 3 they called us out and said, what's the problem? And we identified the problem, and it was microbiologically induced corrosion. So it was the water and the bacteria in the water that was finding places to set up, and then it actually produces an acid that can reduce steel at the rate of 1/4 inch a year, and that was their problem. So they had to stop that problem. Kind of an issue, because now they have pinholes, and they're going to have more, but to stop more pinholes from occurring, they've got to treat that water and keep that sulfate reducing bacteria from setting up on the piping and exuding that acid to cause that corrosion. So on that analytical log sheet, the one you saw previously, that showed the water, the total soil, and then the available soil nutrition, these are some of the little cells that we show for the treatment recommendations. So treatment rates and timing, and then those flow over into what we call remediation phase 1 cost, and then sustainability phase 2 cost. And so it shows the amount of chemistry it's going to be required, and then the cost to the grower. This was a little test that was done just to show the total soil digestion, and then it said, all right, well, show us the available soil nutrition of untreated water, and then spike it with your material and show us the difference. And so some of the standouts on this was, in both cases, we were deficient of phosphorus, which you gotta have, but there's massive amounts in the soil. We're deficient in zinc, yet there's massive amounts in the soil. We have a huge opportunity to create, if we have a lot of bacteria, to create black layer because of the amount of sulfate in the soil, sulfur and sulfate. And then you could see we had no available copper, and yet there's massive amounts in the soil. You could see that the percent of sodium in the drink is in excess of that 40%. And when we were able to release more of the calcium and magnesium, we were able to lower that into below the 40%. So now the plant's getting a good drink, but it's not getting the micronutrients it needs. And all of these are indicators, because of the blue up top, that we've got, we need more antiseptic. It's tied up because of the biology. So it's that simple for us, and it'll eventually be that simple for you. This was a sample. This is actually in agriculture, and the red is just showing you that this is chronic throughout agronomy, everywhere you go. Even where you get 48 inches of rain or 6 feet of snow, we're not flushing these salts. So what they did here is they took the available nutrition and then did a total digestion. And this is parts per million, which actually through math converts to pounds per acre. And so in one of these, we had 5,694 parts per million of iron. So that's over here on the right, top right under iron. And that's actually 15,630 pounds per acre of the top 4 inches of the soil sample of iron. Okay. In one of these, we had 13,180 parts per million of calcium, second one down on calcium. And that's in the top 4 inches of this soil. We had 36,179 pounds per acre of calcium. So how could, if we're calcium deficient, how could we possibly in our mind want to add more calcium? What we need to do is find a chemical that's going to break down this calcium in the soil and move it into available soil nutrition for my plant to drink to reduce these quantities. My only other solution is to remove it, core aerify, remove the plugs. But what do? I remove 30% and I retain 70% of that calcium in 70% of my soil, and then I fill that hole with bad water and add more calcium. It doesn't work. You've got to break it down. You've got to move it. And you can't bury it and top dress it sustainably. So notice all this calcium, magnesium, potassium, and phosphorus, sulfate and iron. Manganese is growing significantly accumulated as well. This is real life agronomy and what's been going on. The U.S. Department of Agriculture Agronomy Manual has a little paragraph about the toxicity of accumulated nutrition. Well, it's chronic throughout the nation. All right, so I got to share this with you. Did you know? So I hear it all the time. Well, rain flushes my salts, and guys, it's not happening. You get this flush of growth for a reason. And that reason is that you bring pure water, you bring oxygen, water flowing through the air, you bring some nitrogen, but that pure water and oxygen oxygenates the nitrogen, oxidizes the nitrogen into NO3, and your plant gets this great drink and it grows. But what happens after the plant's drank that? The next thing it's drinking is sodium, because that's the next soluble salt. And if you go into those soils after a big rain and you look at those beneficial cations and metals, they did not move. those pounds per acre are still there. And that's what we need to fix, and that's what we fix. The bioexudates, I mentioned they produce water, so that's something to think about. This pure water and oxygen from a rain is not going to reduce bioexudates. It's going to add oxygen to kind of help out with the depletion of oxygen from sulfate reducing bacteria, but it's not going to reduce that sulfate reducing bacteria significantly at all. Plants are what they drink. So, we use wetting agents, we use EDTA, we use chelants, we use surfactants. It's not making soluble salts that a plant will always be able to drink. And if it doesn't get totally consumed, if the chemistry doesn't get totally consumed in the soil, you're still adding to soil bulk density and the accumulation of matter in soil porosity, and that doesn't help. If you have a product that is converting the minerals and metals into EC or into TDS, then it's beneficial. But you got to make sure that it's creating sustainable EC and TDS so that when it evaporates to dryness, it doesn't recrystallize. That's our world. And then I want to talk about EC. So I had a golf course call me where he's on a prescription to fix his greens, and he calls and he's concerned that his EC is increasing. I said, well, you're taught that if EC goes up, it's bad. But and typically it is, but you got to look at the other side of the equation. If you have crystals of nutrients that are in the soil and you start breaking them down, what happens to your EC? It goes up. What happens to your infiltration rate and depth? It gets better. So it's a bell curve. So as you're dissolving these crystals, EC goes up, and then eventually when you've moved those crystals through the soil or your plant strength them, it goes back down. And if you sustain soluble nutrients, then you're going to be able to sustain and manage those EC values. So a high EC would be beneficial if it was all nutrition, but it would be horrible if it was all sodium. So something to think about, something to learn, something to add to your book of practices. Okay, so when we do the analytical work, we've developed tools so that in 1 to 2 days we can take that analytical data and turn it into to the economical numbers. And so it's really simple for us to go into a sheet, lay out exactly what you need, show you what the initial year is going to look like, show you what the next year is going to look like, equipment-wise, chemistry-wise, analytical-wise, and we can put that out in literally minutes. Then we have a cost versus value offsets and gains where we can pass that over to the client and say, all right, so here's all the things we're going to do for you. What are you spending on that today? And the reason that this is so valuable, one of our first clients that was on the program 3 years later says, hey, I got to share this with you. I said, what's that? He goes, just my sod budget that I didn't have to buy anymore paid for your entire program. That's pretty significant. What else did we save him? Of course, we didn't ask the question, but it's that significant. And when you lay that over to the finance side and the budget side, total game changer. So I hear a lot about, well, our budget's fixed. Well, yeah, but why don't you take some of what you're not going to need to spend and move it into something you can spend and then capitalize on the gains that you're going to make? And the question is, well, what are those gains? Well, add it up. And you can actually quantify those, the value, not only the value, but the economics on that, the accountability of it. So these are the little cells, the additional cells on the proposal. So we can say, all right, here's the analytical tests you're going to need to do. Maybe you've already done some, but now here's what you should do next year. Here's the chemical that you're going to use, and then here's the chemigation equipment that you're going to use. So as I mentioned earlier, typically existing pumps aren't going to work. Existing controller systems aren't going to work. And I told you the reasons why. This is a typical scenario of an arid environment, 100-acre golf course on costs. So you're looking at testing of about $1,200. That's pretty good, robust testing, doing their water and two soil tests for total digestion and available nutrition. And then the chemistry, a tote of the acid, a drum of the biocide, and then some topical sprays for year one, which you may not need year two, and then for a chemigation system. So that's the smart box, the acid pump, the BC pump, septic pump, and then the mounting equipment, and then preparation for replacing, for doing an annual maintenance on the pump. So we talked about chronic throughout conventional chemistry. Well, these are kind of the things that people see. So accumulation of nutrients, we can show you that by data. The unavailable nutrition, they know it. The hindered pore space, they see that through infiltration, standing water, septic soils, black layers, slosh, localized wet spots, bacteria and waste products, black layer again, stinky soils. They put more nutrition on. It literally is making it worse in the soil. Might give the plant a little bit of push, but it's only temporary. And then we're spending all this money on aerification and top dressing, which really is moderately effective at making sustainable soils, and it's very expensive. So let me say this, if pH reduction is supposed to make available nutrition, and gypsum is supposed to create available calcium and flock soils, then why do we have so much calcium, nitrogen, and iron in our soils, and we need a mallet to get a probe into the ground? It's not working. How did all these nutrients accumulate in our soils that have also cemented, sealed up, and also turned septic? It's the accumulation of nutrition, calcareous nutrients, and minerals and metals in our soils. UC Davis did research on that years ago. I don't know why anybody didn't subscribe to it. So there's a study. It's on our website. Just go to our search bar, type in UC Davis. You can look at the whole study. But right here, it says strong acids will not dissolve salts of strong acids. So when you add gypsum and calcium and you acidify, your plant gets a drink, but what it didn't drink is going to evaporate to dryness, form a denser calcium sulfate, and the acid won't break it down, so it's going to accumulate in the soil. And sulfur and sulfate is food source for bacteria, for sulfate reducing bacteria, aka black layer, which is going to produce toxic waste products. So you can read all about that. I'm a strong acid. WaterSOLV Curative and Fix is a strong acid, but I'm not just acidifying. I'm acidifying, then sequestering, making a soluble salt that will never recrystallize. I can take 1 gallon of my acid and do more than 9 gallons of 93% sulfuric acid, and I can do more than 18 gallons of n-phuric because I will acidify those salts, break them down, and sequester them. This is the formation of scale. So it starts at the top and it goes to the right, and it says what we have is ion pairing, then aggregation, then nucleation, then crystalline growth. It's like growing rock crystals in science class in grade school, and then you accumulate all these crystals. So on the left, if I'm treating soil, I've got to break down those crystals and get them back into the ion pairing state. And if I'm treating water, I'm sequestering them to keep them in the ion pairing state. So that's what I'm doing. I'm putting the chemical in to do the sequestration, then additional chemistry to start breaking down those crystals to get them back into the ion pairing. but I have to include my antiseptic because biomatter will play a role in that complexing. And there you have it. I got this picture about 3 months ago, and they called and said, we have a problem. I go, what's the problem? And he said, we only get 30% the number of strawberries in our boxes. We got to find 70% more boxes now because we're harvesting. Good problem to have. They spent less money and they got 70% bigger crop. And they used, I don't know how much less water they used. This is when we first got started in Tulare, California. They told the guy he shouldn't even buy the soil because it was so bad. They spent $6,300 on product and they made an additional $1.2 million in revenue. Their grapes went, their grade went from 3 to grade 1. They went from 1,700 to 2,500 boxes per acre. They had 100 acres. They saved money on harvesting because they were 2 clip bundles on the grapes. And this harvester said these were the best grapes in that valley in 20 years. So cost, return on investment, and perspective were about the same cost as sulfuric or n-phuric acid, but a lot less expensive with the volume and the handling. The capital costs of WaterSOLV compatible pumps. It's likely a pump controller for variable flow rate systems. They may have to add. The pumps are very inexpensive and they're actually less expensive than some of the higher end acid pumps. The cost reductions are usually double the cost of the chemistry and equipment for 1 or more years. I've had some people that said it was a 15-fold return on investment. The additional yields and efficiencies are significant to the bottom line. Frequently asked questions. Some of these, that we highlighted, I won't go through all of them, but we're a packaged good product. So we're going to deliver a product. It's going to connect to the pump. You don't have to worry about bulk deliveries. The safety is phenomenal. I can get the acid on me, leave it on me all day long. I don't want to get the biocide on me. It'll turn my skin white and it won't stop burning until it's degraded. So I have to rinse it off for about 2 or 3 minutes. Definitely don't want to get that product in your eyes, period. We're the only one out there that actually detoxifies the sodium. We're the only one really going after the bioexudates. What we can do to reduce black layer and iron bacteria films and the anoxicity of soils and add oxygen, uniformity and predictability. Happy owners, management, members, and guests is pretty priceless. And then increased revenues from the amount of play, the revenue from the play, the revenue from the commissary, all those things add up. That's my hand in 0 pH curative and water dissolving a seashell. However, I got to share this with you. You can oversaturate that acid with calcium and it will stop dissolving calcium. So you can have a 0 pH, calcite, calcium, whatever, in the solution and not be able to dissolve calcium. So in wells, we might dissolve scale in a well. We don't find very many of them, believe it or not. We might dissolve them at 5% solution 3 times versus 1 time at 15%. That's the saturation of chemistry. It happens in water treatment, etc. So understanding that is really important when you're trying to descale something. In agronomy, it's not such a big deal, but if you're trying to descale a pipe or descale a well or descale something, you're better off doing 5% increments multiple times than doing 1 time at volume because you'll hit that saturation. These are our packaged chemicals, just food for thought. 2 of those totes replace a tanker load of 93% sulfuric acid and I can put my hand in that chemical and leave it on all day. The fumes are not corrosion inhibited. The vapors of the condensate of the chemistry is not inhibited. It will burn your skin. But the liquid itself is inhibited. So there's chemisorption chemistry in the liquid, which is what makes it non-corrosive. And what is non-corrosive? Non-corrosive by ASTM standards means less than 4 mils per year of mild steel deterioration. Well, 4 mils per year is equivalent to 1/4 of an inch every 10 years. So I don't think that's very non-corrosive. A lot of data online. If you go to our YouTube channel or our Vimeo channel, you can see studies we've done on chlorine corrosion, antiseptic corrosion, tests we showed where sulfuric acid will dissolve iron but not calcium. It'll dissolve steel and iron but not calcium. The comparison to how our product will not dissolve steel, will dissolve iron and dissolve calcium. Tons of analytical data that we're bringing forward. Seeing is believing. We've done the work. A lot of testimonials there from reclaimed water, dead-end lakes, concrete for soil, who 2 years later has 12-inch roots using this reclaimed yucky water. Just tons of great information. The one on the bottom left tells us about the 15-fold return on investment, et cetera, et cetera. So this is all online for you. We wrote articles. You want to know about our products. You want to know about the program. You want to know about case studies. You want to know about the offsets and the values. You want to know about research that we did and the research documents. They're all online. You want to see some of these images and additional images that I haven't had time to share with you. They're all online. You can save them. You can copy them. You can share them with customers. Just right click, copy image, copy link, post it, send it. Our website, if you go to the top and type in a keyword, you're going to get the relevant documents. I was looking for something we did probably 7 years ago, and I just typed in tomato, and there it was. So it saved me a lot of time, and it got me what I needed for the client, and I emailed them the link, and it took me, a minute. I've written articles on our homepage on the left, HCT University. We like people to learn what we're doing, and we will give them a certificate of certification to understand our technology. So there's an article there on sodium, E. coli coliform, shells, chemigation, infiltration, everything you could think of. I was worried about getting hit by a bus. It almost was a car about 6 months ago. So it's all there. Our analytical testing webpage, you can read about how to take soil analyses, why you would do this and that, the different tests. You can look at the form that we use to fill out. I talked about the testimonials and the lab videos already. There's our chemigation page, all the manuals. We have all these little how-to videos that we created. Every little thing you could think about changing, the diaphragm pump that's on it, the plunger pump actually, how to put the quills together, why you put them together this way, how you work with the controller and do the settings, etc. So everything you could possibly imagine, we've tried to put online so you can look at it at your leisure. Here's the tiles. We're here for you. So the best thing we can do is have a dealer tell an end user what we can do for them. That dealer can look through and say, yeah, I want to talk to them. And we can get online and we can have a conversation with you. And we'll take it from soup to nuts and consummate the deal. Our success ratio with people that we engage with is well over 98%. And I handle all the technology and sales. Our dealers handle sales and some technology. And then Marcus Eden, my son, he oversees all the administration, logistics, takes care of our website. I have my daughter who takes care of all our social media and our blog and things of that nature. And I have a son that's actually learning all the well and soil intellectual knowledge, etc. So we're here from you. Odds are you contact us today, you're hearing from us today. What they are saying, this is a link you can go to. You can type that into our website, and there's a whole list of all these different things that people have said about our technology. These are a couple must-see videos on our website. So this is kind of loaded, so you could click on the image and go to that particular deal. But each one of these, which you can recognize the image, are pretty amazing. They shocked me, and the two in the opposite corners on the right and the left, top right, bottom left, blew me away. The bottom right one blew me away. The top one was something we did to in our mode of research, trying to compare RO water to different types of scale and things like that. So I've had customers in seedling operations actually sell their RO systems because of our chemistry, and that's a pretty big financial deal. Here's a whole bunch of the problems we solve. So I can hand that off to somebody in agriculture or somebody in turf and say, if you have any of these problems, I got a solution for you. And it'll actually probably make you more money than you'll probably spend as much as you're spending and save more that you're spending with the things that your current solutions aren't doing. So this is a really good leave behind. Use cost is an interesting thing. I can't believe it took me years to figure it out. But think about this, and it's kind of interesting with sulfurous acid programs because each year, based on their test, you have to use more. Where each year, based on my test, you wind up using less. But if you buy a product at $4 a gallon, but you have to use 60 gallons per acre, let's say, then or 60 ppm, your use rate is 240 gallons. But if you buy a product that costs $30 a gallon and you only have to use 3 gallons per acre, or let's say 3 ppm, your use cost is only $90. So it's a huge number. So why buy cheap at 4 and use 60 or spend 240 versus buy wise at 30 and use it 3 and only spend 90? And then you have to ask yourself the question, well, what's sustainability between these products? What are the additional costs? What are the additional savings? So this is our world, and that's why use cost is so significant. So that's it. We appreciate your time. I hope we answered more questions than we created. We're here. We love to hear from you. We'll give you references, anything you need. And my sign-off comments are, I hope you have a blessed day, and please look both ways at those intersections. Thank you.